You think you're big, right? But compared to the universe, how big are you really? Let's start by wrapping our minds around the concept of the universe. Imagine a vast space, a cosmic canvas stretching in all directions, peppered with a multitude of stars, galaxies, and celestial bodies. It's so expansive that our human minds struggle to comprehend its sheer scale. To give you some perspective, let's use some familiar objects as a reference. Picture a grain of sand. Now imagine that grain of sand magnified to the size of Earth. That's a pretty big grain of sand, right? But in the context of the universe, our entire planet is not much bigger than that grain. And what does this vast universe contain? Well, it's filled with galaxies, each teeming with billions, sometimes trillions of stars. And around these stars twirl countless planets, each with their own unique characteristics and potential for life. Take our Milky Way galaxy, for instance. Nestled within its spiraling arms are around 200 billion stars, and around most of these stars orbit planets. And the Milky Way is just one galaxy among the estimated 2 trillion galaxies that make up our universe. Each star, each planet, each galaxy is a small piece of a cosmic jigsaw puzzle, contributing to the grand portrait of the universe. And yet, despite the vastness of the universe, it's fascinating to think that each of us, in our own way, is a unique and integral part of this cosmic masterpiece. So, let's delve deeper and explore the celestial bodies that adorn our cosmic canvas. Let's journey through galaxies far away, visit distant stars, and probe the mysteries of the universe. So while you might feel big in your own world, in the grand scheme of the universe, you're actually quite small. But remember, no matter how small we may seem, our curiosity and thirst for knowledge make us a significant part of this grand cosmic journey. Now that you know how vast the universe is, how do we measure it? Well, in the realm of astrophysics, we use some unique units of measurement. You've probably heard of light years, right? Contrary to popular belief, it's not a measure of time, but of distance. Imagine this: light travels at an astounding speed of about 186,000 miles per second. So, a light year is the distance that light can travel in a year. To give you an idea, that's about 6 trillion miles. But the universe is so vast, we needed an even larger unit of measurement. Enter the parsec, which stands for parallax of 1 arc second. A parsec is equivalent to approximately 3.26 light years. In the grand scheme of the universe, a parsec seems more like a stroll in the park. So, how do scientists use these measurements to understand the distance between celestial bodies? Well, for nearby stars, they use a method called parallax. It's a bit like the effect you see when you hold your thumb up and close one eye, then switch eyes. Your thumb seems to move against the background. Astronomers do the same thing, but with stars and a 6-month interval between observations. The tiny shift in position allows them to calculate the distance to the star. For galaxies and other distant objects, we use redshift. As light from an object travels through space, it gets stretched due to the expansion of the universe. This stretching shifts light towards the red end of the spectrum, hence the term redshift. By measuring this shift, we can estimate how far away an object is. But remember, these measurements provide us with estimates. The universe is constantly expanding, so these numbers are always on the move. However, these mind-boggling numbers and units of measurements help us grasp the enormity of our universe. So, the next time you look up at the night sky, remember you're not just looking at stars, you're looking across light years and parsecs into the vast expanse of the cosmos. What if I told you that the universe is not static, but is actually expanding? Awe-inspiring, isn't it? The universe, with all its galaxies, stars, and planets, is not standing still. Instead, it's stretching and growing larger with every passing moment. This is the concept of the expanding universe, a theory that has revolutionized our understanding of the cosmos. Let's delve a little deeper. The idea of an expanding universe stems from observations of distant galaxies. Scientists found that light from these galaxies was redshifted, meaning the light waves had stretched to longer, redder wavelengths. This redshift suggested that the galaxies were moving away from us and from each other. The farther the galaxy, the more significant the redshift, indicating that these galaxies were speeding away at higher velocities. But wait, there's more. The universe's expansion isn't just happening at its outer edges, it's happening everywhere. Imagine a loaf of raisin bread dough in the oven. As it bakes, the dough expands, and the raisins, representing galaxies, move farther apart from each other. The dough, representing the fabric of space, is expanding, causing the galaxies to move away from each other. Now let's talk about the cosmic microwave background radiation, a sort of afterglow from the Big Bang. This radiation is a snapshot of the universe about 370,000 years after the Big Bang, and it's remarkably uniform in all directions. This uniformity supports the idea that the universe has been expanding in all directions since its inception. The evidence supporting an expanding universe is compelling, and it's a concept that has reshaped how we view our place in the cosmos. As we sit here on this tiny blue dot we call Earth, the universe around us continues to grow larger. This expansion is a testament to the dynamic, ever-changing nature of the universe. Yes, the universe is getting bigger every second, and we're all part of this cosmic expansion. The universe is so big we can only see a part of it. What lies beyond our vision? Just think about it for a second. The universe is so vast that even with our most advanced technology and the speed of light on our side, we can only observe a fraction of it. This fraction is what we call the observable universe. It's like a bubble with us at the center, extending outwards to as far as light has had time to reach us since the Big Bang. That's about 93 billion light-years across. But here's the thing, if the universe is indeed infinite, as some theories suggest, then our observable universe is just a tiny, tiny dot on the cosmic canvas. We're like ants trying to map out an entire forest from the perspective of a single leaf. So what could exist beyond our observable universe? Well, that's where things get really speculative and exciting. Some scientists believe there could be other universes, a concept known as the multiverse. These other universes might have different physical laws, different dimensions, or even different versions of ourselves. Others theorize about the existence of cosmic structures that are so large they're beyond our current ability to detect. Just imagine, there could be galaxies, stars, and planets out there, completely different from anything we've ever seen, existing in regions of the universe we can't yet perceive. Current technology has its limitations, and there's only so far we can peer into the cosmos. But every day, we're pushing those boundaries, trying to expand our cosmic bubble just a little bit more. So the universe is not only incredibly vast, but also largely unexplored. It's a cosmic mystery waiting to be unraveled. Each discovery we make is a step closer to understanding the grandeur of the cosmos and our place within it. So let's keep looking, keep exploring, because who knows what wonders lie just beyond our cosmic horizon.